Hi everyone. In previous videos, I have shown how to use different methods to calculate the current in simple diode circuits. In this video, I will compare different methods and will explain in what situation each method can be used. For comparison, I have tried to use the same parameters for diodes in all methods as much as possible. I have used three different values for the applied voltage. Very small voltage, 1.5 volts, a medium range voltage of 12 volts, and a very large voltage of 100 volts. So these are the results that I have previously calculated based on different methods. As you can see, when the voltage is 100 volts, they are nearly the same. They are all about 50 milliamps. There is no big difference between these values. The difference actually is less than 1%. So when the voltage is very large, it doesn't matter which method we use. Any methods that we use will give you a precise answer. However, if we come to small values of the applied voltage, for example 1.5, you can see that if we use ideal diode, it gives you 0.75 milliamps. But if we use a precise method, it will give you 0.44 milliamps. So there is a big difference, nearly twice, or 100% error. And even between different methods which are precise, you can see there are some differences. In medium range, there are some differences, but these differences are small. The only big difference is when we have ideal diode. In the other cases, they are very close. So when we use each method, for ideal diode, we use the ideal diode model when the accuracy is not very important and we just want to have a rough estimate of the current. However, it is very accurate when the applied voltage is very large. For example, here, when we have got a voltage of 100 volts, you can see that there is no big difference between the results of the ideal diode and the other methods. The calculation error is very large when the applied voltage is small. It's close to the forward voltage of the diode. The constant voltage model, it's usually used most of the time, nearly always, in diode circuits calculations. It is very accurate even at small applied voltages. Remember that the forward voltage of LEDs and power diodes at high currents could be much larger than 0.6 or 0.7 volts that we usually use for silicon diodes. For LEDs, it could be even close to 4 volts, 3.5, 4 volts. The piecewise linear model, the difference between piecewise linear model and the constant voltage model is that in this case we apply a forward resistance as well. The effect of forward resistance when the current is low or medium is not important, is negligible. So in these cases, using the constant voltage model is enough. The main application of piecewise linear model is in power circuits when the diodes have very large currents. In power diodes or in high currents, usually we have a series resistance which in small currents we ignore that, but in large currents the drop across this series resistance is important, and because of that we need to use the piecewise linear model to have an accurate result. Using the diode equation or precise method, obviously we use it when we want to have a very precise values, when the precise values are important. If we want to use this method and if we want to have precise values, we should have the exact diode parameters. For example, saturation, reverse saturation current, and ideality factor, we should know them. The method is the basis of the numerical analysis by computer programming or simulations. In videos, I have shown how we can use this manually, but usually it's not done manually. It's by computer programming. The graphical method, it's a very precise method if we have the diode IV characteristics. The accuracy of the method depends on how we draw the plots and how we measure the values on the graph. Its main application is to explain the ideas or understand the concepts. Circuit simulation, maybe it's the most precise method if we have the right models, and also we can manage to set up the simulation properly. Probably you don't need to analyze simple circuits like that by simulation. However, it can be useful to understand the concepts. Thank you for watching.